Question 7 of the C34 paper, June 2015. We've got t equals tan x. Now we can see a few things going on here with the trying to get it from here to here. First of all, we've got a formula for tan 2x. It's quite handy. Tan 2x is equal to 2 tan x over 1 minus t squared. So that's pretty useful. We also know that sec squared x is 1 plus t squared, and cot x is 1 over tan x, so that's 1 over t. So let's go for it. I don't think this is going to be too much trouble. For tan 2x minus 3 cot x sec squared x equals 0. So that gives me, as we've just said, let's go up here, 4 times by 2t 1 minus t squared minus 3 times by 1 over t, that's a cot x, times by the sec squared x, which is the 1 plus t squared, equals 0. Okay, so that's it. If I multiply through by t 1 minus t squared, okay, every term, the first term is going to be 4. The 1 minus t squared will cancel, so I'm going to have 4 times by 2t times by t. The second term, the t is going to cancel, so I'm going to have 1 minus t squared 1 plus t squared equals 0. Okay, this is really not a big problem. So this first term is 8t to the 8t squared. This is a difference of 2 squares, so that's 3 times 1 minus t to the 4 equals 0. And that's got us there. We've done enough to, surely that's enough to convince whoever's reading this that we actually know what we're doing. It's a convincing argument. We've shown it. There we go. Done. Okay. Now there's the part B. Sometimes when you're using part A to part B in these types of questions, they disguise it a little bit, but there's no disguising what's going on here. I suppose maybe they think that dealing with that, we've got enough on our plate dealing with that, but it really should be fine. So 4 tangent 2x minus 3 cot x sec squared x equals 0. So that's just going to reduce to this equation, 3 tan, oh, that's not right, tan, we might as well use t's. Nice, a little bit less writing to do. We like these little shorthands. Now that factorises. Now some people are a little bit uncomfortable with the t to the 4. So feel free to to reduce this to y squared, or let t squared equal y if you want, and then do 3y squared plus 8y minus 3 equals 0. Solve for y and go from there. I'm not going to do that. To me it seems that I'm not doing that, but you can. Can be quite stubborn sometimes if it seems a little bit childish. I'm not going to do it. So now here we go. Plus 3 and minus 1. There we go. So minus t squared, 9t squared. There we go. That's not relevant. So we can't have that. And here we've got 3t squared minus 1 equals 0. Quite a few people got to here. What a lot of people did though at this stage was they got to t squared is equal to 1 over 3 and just said that therefore t was equal to 1 over the square root of 3, and thereby lost some solutions because of course it's plus or minus 1 over the square root of 3. So we're solving two equations. Tan x is equal to 1 over the square root of 3, and tan x equals to minus 1 over the square root of 3. Right, now tan x equals to 1 over the square root of 3. They want us in terms of pi. Well, we should know our angles really. We really shouldn't need a calculator here. Now, we're going between the range 0 and 2 pi. Now, let's just think here. I'm going to think in degrees, but I'm going to write my angle in radians. The inverse tan of 1 over the square root of 3, the value the calculator is going to give you is pi over 6. And also, you're going to have 180 plus that, or pi plus that, so that's 7 pi over 6. Just add pi, and with tan it's nice and easy. If you get one solution, add in pi or 180 as many times as you like. I'm going to give you other solutions. If I add another pi to that, I'm outside my range, so I don't need to do any more. I'm outside the range. I'm just rubbing out there. Okay. Now, this bit, the principal value, tangent x is minus 1 over the square root of 3. Okay. Now, that's going to give us minus pi over 6. But then I need to put lots of pi from there. So I'll get the calculator will give me the principal value is minus pi over 6. Okay, so again, it's okay to use a calculator, you are allowed, but I haven't used a calculator to do that. So that's minus pi by 6 is outside the range, but I'm going to keep adding lots of pi. So it's 5 pi by 6. The tangent is really the nicest to solve in many ways. 5 pi by 6, add another lot of pi to that, and we get 11 pi by 6. So there we go, we've got all four solutions. I'm going to write them out again in order. Okay, don't have to, I think that would be okay, and I think it would be ignored, the fact that that one's outside range, but let's write them in order anyway. Done all the hard work, we might as well make sure that it's 5 pi by 6 much as well. Make sure that it's all done and dusted, and there can be no doubt that we are knowing what we're doing. Okay, I thought that was not the hardest of trigonometry questions. Quite a few good answers. The most common mistake, and it is a surprising thing to miss this negative, because we see it so often where that is the case. So it's just something to watch out for. Okay, that's it.